Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation for trouble code P1157, which indicates an AF sensor AFS circuit high voltage issue, specifically for the Honda Civic models from 2006 to 2011. This code alerts us to potential issues with the air-fuel AF sensor located in the exhaust system, particularly the sensor 1, which plays a crucial role in determining the optimal air-fuel mixture for engine efficiency. The sensor's location is just before the catalytic converter, providing real-time readings to the engine control module, ECM, or powertrain control module, PCM, to adjust fuel inputs accordingly. When the AF sensor reports high voltage, it can lead to poor engine performance, increased emissions, and potential damage over time if not addressed. In this session, we'll explore detailed steps for troubleshooting this issue, including the necessary diagnostic procedures and checks to conduct. By understanding the symptoms and methods to resolve the DTC P1157, we can ensure a smooth and efficient driving experience. DTC P1157 refers specifically to the failure of the AF sensor, also labeled as sensor 1, which is integral for monitoring the air-fuel mixture entering the engine. This sensor's primary function is to measure the concentration of oxygen in the exhaust gas, enabling the ECM or PCM to make real-time adjustments to the fuel injection system. It is installed in the exhaust manifold, just before the catalytic converter, strategically placed to provide the most accurate readings of exhaust emissions. A high voltage error can occur due to various reasons, such as faulty wiring, sensor failure, or environmental factors affecting the circuit, as the air-fuel mixture heavily influences combustion efficiency and emissions. Understanding the root cause behind a high voltage reading is paramount. Proper function of this component is essential not only for vehicle performance, but also for regulatory compliance with emission standards. When diagnosing DTC P1157, certain possible causes must be thoroughly examined. One primary suspect is the AF sensor itself, where internal faults can lead to high voltage readings and erroneous data being transmitted to the control module. The wiring harness connecting the sensor to the ECM can also cause issues. Damaged or corroded wires may interrupt communication or produce false voltage signals. Another potential issue is malfunctions within the ECM or PCM, where internal faults might result in incorrect interpretations of sensor signals. Additionally, loose connectors or poor grounds can contribute to intermittent failures, leading to unreliable data transmission. The overall integrity of the circuit must be vetted to ensure operational efficiency, which is crucial for optimizing performance and minimizing emissions. The manifestation of DTC P1157 can lead to several noticeable symptoms that affect vehicle performance. The most immediate indicator is the illumination of the check engine light on the dashboard, which signals the driver of an underlying issue needing attention. Owners may also experience poor engine performance, characterized by reduced acceleration, rough idling, or stalling, as the fuel mixture may not be accurately regulated. Higher than normal emissions could also be another symptom, leading to potential failures in emissions testing, which is critical for regulatory compliance. Increased fuel consumption may also occur as the engine attempts to compensate for a lean or rich mixture resulting from sensor inaccuracies. Overall, recognizing these symptoms can prompt early intervention, preventing further damage or more extensive repairs. The first step in troubleshooting DTC P1157 involves ensuring the ignition switch is turned to the on position. This action powers the vehicle's electronic systems, including the ECM, PCM, allowing for diagnostics to proceed. Before initiating any reset, It is crucial to document all freeze data and onboard snapshots. Freeze data captures the last recorded parameters at the moment the fault occurred, which can provide invaluable information regarding engine conditions and sensor performance at that time. The onboard snapshot may include additional diagnostic trouble codes, DTCs, that could relate to ongoing issues. Additionally, reviewing the general troubleshooting information as per the manufacturer guides ensures that standard protocols are followed, further guiding the diagnostic process to avoid missing critical checks. The next troubleshooting step is to clear the DTC using the Honda Diagnostic System, HDS. The HDS is a specialized tool designed to interface with the vehicle's onboard computer, allowing for a comprehensive diagnosis and troubleshooting of issues like DTC P1157. Clearing the DTC will reset the error condition and clear any stored trouble codes that may influence diagnostic parameters. After the DTC has been cleared, it is essential to proceed with the next steps without hesitation, as the system must be re-evaluated under real operating conditions. This action will help ensure that any potential intermittent faults are reliably identified, allowing for subsequent checks for any new DTCs or events that may arise. Monitoring the data after this reset is crucial, as it provides a fresh start for analysis. After clearing the DTC, the next step is to start the engine and allow it to idle for about 1 minute. This wait time is necessary to enable the engine and associated systems to stabilize and reach optimal operating conditions, ensuring any underlying issues can be accurately detected. During this period, the AF sensor will start to function, providing crucial readings to the ECM/PCM for adjustments to fuel delivery. After this minute has elapsed, check for any pending or confirmed DTCs using the HDS again. This check will confirm whether DTC P1157 persists or if any new codes related to the air-fuel sensor appear. If DTC P1157 is still indicated, it suggests a persistent issue needing further investigation, while a lack of new codes could indicate an intermittent issue that may require further inspection of terminals and connections. Upon checking for DTCs, if P1157 is indicated, the troubleshooting process must continue to identify the exact problem. If DTC P1157 is not present, this may signify an intermittent failure within the system. Here, it is paramount to examine the connection integrity at the AF sensor and the ECM or PCM for potential loose terminals or poor connections. Such minor issues can lead to major discrepancies in sensor data, often resulting in inaccurate voltage readings. If the code is indicated, however, it directs our attention toward the components and wiring involved in the AF sensor circuit. This step signifies the importance of focusing on key areas for further inspection to isolate faults leading to excessive voltage readings and correct any issues accordingly. For Step 5, the ignition switch must first be turned to the lock 0 position. This action ensures that no electrical systems are powered while performing the next set of diagnostics. Next, connect the Honda Diagnostic System, HDS, and locate the SCS/SRS check connector line, which allows the technician to access specific test modes required for diagnostics. Jumping the SCS line initiates a precondition that ensures the HDS can accurately read data from various vehicle sensors, including the A-function sensor. This step is essential for pinpointing faults related to the air-fuel sensor circuit and preventing signals from interfering with each other during diagnosis. Ensuring the correct operation of the SCS line in conjunction with the HDS is crucial for obtaining reliable readings during tests. Following the setup from Step 5, the A-factor sensor's 4P connector must be disconnected to isolate the sensor from the ECM/PCM circuit. This step is crucial in preventing any feedback that may occur from the vehicle's electronic systems while performing further checks. With the sensor isolated, we can ensure that any readings taken during subsequent steps will accurately reflect the state of the circuit, rather than being influenced by the sensor itself. It allows for a more focused analysis of the wiring and connections directly associated with the A-factor sensor, providing a clearer path for troubleshooting. This disconnection is a standard procedure for vehicle diagnostics, confirming that other components do not affect the outcomes of the tests we are about to conduct. In this step, it is necessary to disconnect the ECM/PCM connector C, which has a total of 44 pins. Disconnecting this connector is critical as it allows us to carry out a thorough continuity test that determines whether or not there's a break or fault in the wiring harness. This step is particularly important as a weak or broken connection can lead to the symptom of high voltage at the AF sensor, confirming that the sensor is not the faulty component. By isolating the vehicle's electronic control module from the diagnostic path, we reduce the complexity of the system being evaluated. This disconnection ensures we can assess the wiring independently for faults that could contribute to the high voltage problem reported by DTC P1157. Now we will focus on checking the continuity between the AFAC sensor 4P connector terminal number 2 and the corresponding terminal number C29 at the ECM/PCM connector. This test ensures that there is a proper connection in the circuit that facilitates the flow of data and power between the AFAC sensor and the control module. Proper continuity indicates that the wiring is intact and capable of transmitting voltage signals necessary for the functioning of the AFAC sensor. If continuity is confirmed, it generally allows us to move forward in diagnostics with higher confidence. Conversely, failure in this test may reveal an open circuit, suggesting a wiring fault that must be repaired before further checks can be made. Conducting this test with precision is essential to successful troubleshooting. Upon completion of the continuity test, assessment of the results is essential. If continuity between terminal number 2 of the A full sensor 4P connector and terminal C29 at the ECM/PCM is present, it indicates that the wiring is intact, allowing us to proceed to the next diagnostic steps confidently. However, if no continuity is observed, it highlights an open circuit in the wiring between these 2 points. This failure necessitates immediate attention to repair any defective wiring that may be interrupting voltage or signal flow. Identification of the open wire could involve visual inspections of the harness, as well as physical tests to track down the fault. After addressing and repairing any wiring issues, one must return to this step to verify continuity once again before proceeding with the additional diagnostics. After completing all necessary repairs regarding DTC P1157, it is crucial to perform a final verification to ensure that the issue has been resolved. Begin by using the Honda Diagnostic System, HDS, to clear any stored DTCs. This action resets the error codes associated with the air-fuel sensor circuit. Next, a comprehensive test drive should be conducted under varied driving conditions to assess engine performance and ensure all systems are functioning normally. During this drive, it is important to monitor the dashboard for any check engine light activations and to subsequently recheck for any new DTCs using the HDS. This final step is vital, as it ensures that the repairs made were effective and verifies that the vehicle operates within normal parameters without recurring issues. Proper verification confirms the integrity of the AFN sensor circuit, facilitating reliable operation moving forward. To prevent the reoccurrence of DTC P1157, adopting a comprehensive preventive maintenance strategy is essential. Regular inspections of the A5 sensor and associated wiring are crucial to identifying potential wear or damage before they escalate into larger issues. Technicians and vehicle owners should develop a routine schedule for checking connections to ensure that they remain secure and free from corrosion. Additionally, keeping the A5 sensor clean and ensuring it is free from contaminants that could impair its functionality helps prolong its service life. Environmental factors like moisture or oil can quickly affect sensor readings and operations. Hence, ensuring a protective environment can substantially boost performance longevity. Integrating these preventive measures into regular vehicle maintenance not only minimizes the risk of similar DTCs, but contributes to overall vehicle efficiency. In conclusion, the experience with DTC P1157 highlights critical issues related to the AF sensor and its connection to the ECM/PCM within the Honda Civic from 2006 to 2011. Understanding the function and role of the AF sensor clarifies its impact on engine performance and emissions. The troubleshooting steps outlined provide a structured approach to systematically identify root causes and address any faults systematically. Additionally, the importance of preventive maintenance cannot be overstated. Ensuring regular checks and good practices can greatly enhance vehicle reliability and prevent similar issues from arising in the future. Effectively managing DTC P1157 can lead to better engine performance and reduced emissions, contributing positively not only to the vehicle's operation, but to environmental standards. Please like and subscribe to the channel. See you next time.